find tension 1 and tension 2. What will be the best equation to go and find tension 1? The first one. And tension 2, the second one. That's it. And how do you find the angular acceleration? Angular acceleration. We found the linear, angular. A over R. To have A, you find R, A, the alpha. Alright, let's say that you have the same question now, similar, in the study guide. What is the study guide? Question number 7 on the study guide. What do you see in question number 7? Now we have, instead of the Atlas machine, we have a different system because we have one mass capital in the supporting surface, right? One mass hanging down and the poly. The question, a mass M 4 kg is connected as shown in the picture by a light cord to a mass M 6 kg, which lies on a smooth horizontal surface, no friction. The poly rotates about a frictionless axle and has a radius given, and a moment of inertia I given. So it's not a disk, it's nothing, it's given already the moment of inertia. I is given. The core does not slip on the poly. The question, what is the magnitude of the acceleration of N, which is the same acceleration of capital N? It's the same acceleration, right? Okay, so how can we set up the equation? How many objects do we have? 3 objects. How many equations you should have? 3. What will be my first equation? Let's start with the letter N. Letter N. Without drawing anything, free body diagram, you should be expert now. Tell me what will be the equation for the letter N. Ng minus T, what? There are the tension are the same in both sides of the core? How do you label them? Mg minus T1 equal to what? N1A, first equation. What will be the second equation for the capital M? T2, is there any other force? No, there is no friction. The surface is smooth. So I will have T2 equal to what? M2A, second equation. What will be the third equation for the poly? What will be the torque, the net torque? R times what? Parenthesis, you can put parenthesis, RT1 minus T2 equal? No, it's not 1/2. They didn't say that it's a disk.
I is given here.
I is given. I times what? A over R, which is alpha.
Yeah.
That's it. You have the 3 equations. Get it. You get the acceleration. After you get the acceleration, you can get the tension. Any question? Setting the 3 equations. Everybody can see the 3 equations. So from that, you set the system of equations of the 3 equations, and then you can get the acceleration. Any question? Good. We finished with 1 object or 2 objects. Motion of the rod. So we finished with objects attached to a poly or passing through a poly. The second type of problem, applying the Newton laws, will be the rod moving. The rod moving. So motion of the rod. The motion of the rod. Let's say that we have this rod rotating. Can be about the end or can be with respect to a center of mass. I will use about the end. The first thing we need to know on the rod moving from here, this is the axis of rotation. The typical question will be, given the mass of the rod, giving the length of the rod. Moving with respect to this, with respect to the end, find A, the acceleration of the rod, A, at the end. I have to specify at what point, because A changed with the point. So find A at the end. And find alpha. Alpha always is the same. Let me just put it this way. Find alpha, which is always the same, and find the acceleration linear at the end. Initial, at the initial moment, when it's horizontally, at the initial moment. Then, B, find the alpha and the acceleration when the rod is like this. At, let's say, 30 degrees from here. Find the acceleration. So originally at the initial moment, find the acceleration, then find the acceleration at any angle. So here we are. This is the rod. So the rod will accelerate like this. At the beginning, we'll have acceleration like this. What is the initial acceleration at the beginning? And what will be the acceleration a little bit later? What is the force acting on this rod? Going down. What force is making this able to rotate? Gravity. Everybody can see that the gravity is the force. Good. So if the gravity is the force, the gravity acts always at what point? At the center of mass. In this case, will be here. So, if I want to go, this object is rotating or translating? Rotating. Can you see that the axis of rotation is fixed? Then cannot be translating. The only thing that can do is rotate, because there is an axis that is fixed in direction. So, since the object is purely rotating, I have to go with the Newton law for rotational motion, which said what? What is the Newton law for rotational motion? Sigma what? Tau equal to I alpha, because the object is purely rotating. Now I need to find what is the force creating the torque. What force is creating the torque? Gravity. And by definition, at the initial moment, what will be the definition of torque by the gravity? What will be the torque by the gravity? Let's go. Tell me what is the definition of torque. Well, where we start? In this case, it's not radius. Remember that R doesn't mean radius. What means? What is the meaning of R in the formula? Distance from the axis of rotation to the point of application of the force. That doesn't have to deal with the radius.
Length over 2.
Length over 2. And this is the important. It's not R. Now it's a rod. How can be R? There is no radius. I don't see a radius in the rod. That R has a meaning. Distance from the axis of rotation to the point of application of the force. If you know, you will come and you will say, oh, wait a minute. Distance from the axis of rotation to the point of application of the force, L over 2. Tell you what, the force acting